a closed seam around the vessel's entire circumference. No starting point, no end point to rest. The only way to make it perfectly even: don't move the welding head. Rotate the vessel itself. Below, 4 turning roll units, 8 rollers. The vessel simply rests on them, under its own weight. 1 unit carries a gear motor, pulls the vessel along through friction. The other 3 simply support and free spin. Above, a submerged arc welding head, perfectly still. Flukes hopper, wire spool, not a single millimeter of movement. The vessel turns. The welding head stays still. The circumferential seam is now simply the vessel passing one fixed point around and around. Perfectly even, because the speed no longer depends on a human hand. Open up one turning roll unit, and there's nothing surprising. Just the most familiar mechanical parts. On the drive unit, one simple chain of transmission running from motor to roller. Nothing complicated, nothing extra. But that same simplicity multiplied across 4 units, 8 rollers, is enough to carry an entire vessel weighing tons, turning evenly for hours on end. Inside the welding head, there's one more part, easy to overlook. A small roller and entrist in just to pour the Bristol Impath, riding directly on the vessel's surface, mounted on a spring-loaded slide. The vessel is never perfectly round. A deviation of just a few millimeters, this roller senses it instantly. 4 turning roll units. 1 welding head, nearly still, only adjusting itself to the vessel's true surface. Not a single unnecessary part, only exactly what's needed to keep the distance stable and a weld that no longer depends on human endurance. If you'd like to rebuild this yourself or modify the design, the 3D CAD file is linked right down in the comments.